Hi, good morning. Today we are going to discuss about IMS, IP Multimedia Subsystem. IP is Internet Protocol, multimedia is multiple media types like this audio, video, text and images and other things. With the help of IP Multimedia Subsystem, we can provide multimedia communication for fixed and mobile network users. So let us discuss in detail about the IMS. So IMS is defined by the third generation partnership project for delivering communication based on the internet protocol. So what your IMS is going to provide is real-time multimedia session, that is basic voice calls, video calls and conference calls, and non-real-time multimedia sessions like push to talk, that is walkie-talkie communication, half duplex, presence and instant messaging with the help of IP network. So it brings together all the services of fixed mobile and internet network to provide multimedia services, and it is called as the next generation network. The vision of the IMS is to integrate mobile or fixed voice communication and internet technologies in order to provide internet services to mobile and fixed users. So next is IMS can enable IP interoperability to the fixed and mobile network. So if it is interoperable between the fixed and mobile networks, the data or voice transmission will be seamless between these networks. So the next one is the features. The features are services transparency and integration. So in order to deliver these features, we need two aspects. One is the IP based transport for both real time and non real time services. Next one is by introducing a multimedia call that is based on the session initiation protocol. So we'll discuss session initiation protocol in the next slide. IMS is going to provide. So say multiple multi-service, multi-protocol, multi-access, IP-based network, secure, reliable and trusted service. So what is multi-services? So whatever services that is needed for the user will be provided to the particular subscriber. So next is multi-access. So it can access in different networks, that is the 3G networks in fixed Wi-Fi, WiMAX, CDMA 2000, UMTS cable. It can be able to access from any networks. So next, what is the service providers is going to offer to the user? So first is the real-time and non-real-time communication between the peers, and it is a client-server configuration. That is, if you need any services, the server will provide the particular service for that client. So next is mobility of services and mobility of users, and multiple sessions and services. That is, with the same connection itself, we can able to communicate with many people and we can get communication services anywhere. Next, we are going to discuss about the layers of the IMS architecture. So we have four layers in the IMS architecture, that is the access layer, transport layer, session control layer and application layer. So as we saw in previous slide, IMS is access independent. It can get access from any mobile networks, that is 3G, 4G and other fixed networks like Wi-Fi, WiMAX, cable, DSL, etc. So next is the transport layer. It contains the IP routers for routing the signaling messages and other messages. So next layer is the session control layer. This is the main layer in the IMS, that it contains call session control function and the home subscriber server. The call session control function is used to set up the calls, set up, establish, modify, manage, as well as it can terminate the calls. So it is responsible for the whole call sessions. And next, home subscriber server. It contains the user's profile, the location of the user, and it is a database of the user's profile. So the next layer is the topmost layer, is the application layer. It contains three things, that is application server, multimedia resource function controller and multimedia resource function processor. So the application server is nothing but whatever service is required by the user, it is going to provide that particular service to the user. So the multimedia resource function processor is also called as IP media server. So it is going to provide multimedia services like voice calls, conference calls. It is going to process all the voice calls, conference call, etc. to the users. So this is as a same things. So what are the underlying concepts of the IMS architecture? That is, so in order to design IMS, what are the requirements we need? That is IP connectivity. So as it has to access with any networks, it should have a common protocol, that is Internet Protocol. So it is a access independence. It can access from any networks, any mobile or fixed network. So it ensures QoS from IP multimedia services, secure communication, charging arrangements, that is postpaid or prepaid charging, and support of roaming. Next, interworking with other networks. It is going to work with the fixed and mobile networks, it has to interwork with other networks. Service control and service development. Next is the IMS and Session Initiation Protocol. Session Initiation Protocol is an application layer protocol. So in the previous slide, we have seen the call session control function. The main function of the CSCF is to set up or establish a call, modify, manage, as well as it can able to terminate the call. So these functions will be done with the help of Session Initiation Protocol. So for example, consider a conference call is going on and a participant is being invited to the conference call. So before the call is being connected to that particular participant, an invite message will be sent by the SIP. So that is, the SIP is going to send an invite message which contains the description of the media types and other parameters of the ongoing conference call. So after the call is being accepted by the participant, the call gets connected and the original data flow take place between the users. So here SIP is going to send an invite message and the participant should accept to the message for connecting the call. So this is called session initiation protocol. The key capabilities that SIP provides for managing multimedia communication. So the first one is it determines the destination user's current location. It determines whether the user is willing to participate in a particular session. It determines the capabilities of a user's terminal, whether he can able to participate in that particular session. It will set up a session as well as it will manage a session. Network entities. So first is the IMS terminal. It is an application on the user equipment that sends and receives SIP requests. Even your mobile phone, in order to send a SIP request or receive a SIP request, we need the IMS terminal in order to send it. So next is the home subscriber server. So it contains the main data storage for all subscriber and service related data and provides a user registration as well as the registration information of the subscriber. So next is call session control function. So the function of the call session function is control function is set up or establish a call, modify, manage, as well as it can able to terminate the call. So in general, GSM, when it roams onto your visited network, so the visited network can access the home location register and the call control is done in the visited network in GSM. But in IMS, the call control is done from the home network. So as the call control is done from the home network, it gives rise to three types of CSCF, that is proxy CSCF, interrogating CSCF, and serving CSCF. So let us discuss in detail about these three CSCF. So this is 3GPP IP multimedia subsystem. So in a visitor network we have the proxy CSCF and in the home network we have the interrogating CSCF and the serving CSCF. So once the mobile, that is your user equipment, enters into a visited network, the first point of contact is your proxy CSCF. So let us discuss the proxy CSCF in detail. CSCF is the mobile's first contact point inside the visitor network. So it accepts the SIP request from the mobile and then it forwards to the other servers. So the functions of the CSCF are: it forwards the SIP register request from a mobile to the mobile's home network, forward other SIP messages from a mobile to a SIP server, that is the SCSCF in the home network. It forwards SIP messages from the network to a mobile, and it performs SIP request modifications before forwarding it to the other network entities. It maintains a security association with the mobile, and it detects emergency sessions, and it creates call detail records. Interrogating CSCF is the contact point for all connections destined for the subscriber. So it performs the following functions. It contacts the home subscriber server and obtains the name of the serving CSCF that is serving that particular user. After obtaining the serving name of the SCSCF, it is being assigned to that particular user. The ICSCF is used to forward SIP requests or responses to the serving CSCF. It generates call detail records, and it also provides a hiding functionality that can be used to hide an operator's internal structure from an external network. Serving call session control function provides session control services for a user. That is, it controls all the ongoing session for the registered users. It performs the following main tasks. First is registration. So whenever the user equipment moves to a visitor network, it sends a SIP registration request, and the serving CSCF act as an SIP registrar and make the uses registration and location information available to the home subscriber server. So next is the session control. The SCSCF can perform SIP session control functions. That is, it sends the SIP requests and responses between the calling and the called parties. So next is the proxy server. So the SCSCF act as a SIP proxy server that sends SIP messages between the user and the other CSCFs. So it interacts with the application servers in order to provide the service required by the particular user. So the other functions include that it generates call detailed records in order to accounting and billing, and and also provides service related event notifications. The working between PSTN and IMS. The IMS networks need to interact with the PSTN so that the IMS users can establish service to the PSTN users. So the internetworking between IMS and PSTN occurs at two levels. One is the user plane level, that is the bottommost, and the other is the signaling plane level, that is the top level. In the user plane level, the IP-based media streams have to be converted in the IMS side, have to be converted to TDM-based media streams on the PSTN side. So this conversion is done with the help of the IMS MGW. Similarly, in the signaling plane level, the session initiation protocol signaling messages have to be converted to ISDN signaling user part. This conversion is done with the help of the media gateway control function. The media gateway control function transpose the ISUP signaling message to the trunking signaling gateway. The trunking signaling gateway transposes the ISUP with the help of Signaling System 7 protocol to the PSTN switch. So consider a situation where a call is being initiated at the PSTN switch and it has to be delivered to the IMS terminal. So here the call is being taken from the voice circuit. So once the PSTN switch receives the call, it will generate a ISUP signaling message to the and sends it to the trunking signaling gateway. The TSGW will send the ISUP signaling message with the help of signaling transport over IP protocol to the MGCF. The MGCF, in association with the IMS MGW, creates a context with the help of the Magoko protocol. The context contains the TDM termination and the real-time transport protocol termination. So once the TDM gets terminated, the IMS MGW and the PSTN switch gets terminated, interface gets terminated, and similarly once the RTP gets terminated, the IMS MGW interface and the IMS terminal gets terminated. After the termination, the MGCF originates a SIP invite method that contains the session description protocol that has been written from the IMS MGW. This session invite message has to be sent to the IMS terminal. So this is how interworking is taking place between the PSTN and IMS terminal. Advantages and benefits of IMS are applications, network and device independence, reusable components, standards-based solution, service interconnection, service diversity, convergence and quality of service.